Hello and welcome to week 1, day 1 of Da Vinci Tree's online learning. My name is Matt Roll and I'm here with Miss Kaufman over here.
Hello, good morning.
And we are here every morning as we normally would be at school to do the pledge and joke. But before we begin with the pledge and joke, as always, we want to begin with our announcements. And so our announcement for the morning is discussing the recent first place win at the SARSEF Science Fair for our kindergarten class. Let's give them a round of applause. All right, so Ms. Kaufman, can you tell us a little bit about your experiment that won first place at the SARSEF Science Fair?
Thank you, Mr. Roll, for mentioning our science project. They worked very hard on it. And we did our science project on wondering if you could taste food the same with smell as without smell. And so we found out that it is definitely easier to decipher what food is with smell by our graph and things like that. So we entered it in the SARSEF and we won first place. Congratulations.
Thank you so much, Ms. Kaufman, and again, a big congratulations to all of our kindergartners for winning first prize at the SARSEF Science Fair. That was just fantastic. As you may have noticed, Ms. Kaufman and myself are not standing right next to each other as we normally would. On our videos, we're going to be practicing something called social distancing. So kids, now that there is this virus going around, the COVID-19 virus, you want to make sure that if you are standing next to somebody in public, you are staying about 5 or 6 feet away from them. That social distancing will help keep you safe from getting sick. And so as you watch our videos throughout the days here, you will notice that we are all practicing social distancing. Well, at this time, as always, it's time for us to get our joke of the day in, and Ms. Kaufman is going to be telling us our joke of the day today. So back to you, Ms. Kaufman.
For the joke of the day, it is, how do you know that hot is faster than cold?
How do you know?
Because you can catch a cold. All right, if you're with us today, I want you to stand up, put your right hand on your heart, and face a flag if you have one. Ready? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, I guess we're ready to begin our class.
Hello, everybody. My name is Mr. Roll. Good morning, or good afternoon, or good evening. I don't know what time it is for you because, frankly, this is the internet, and you could be watching this whenever. So, my name is, again, Mr. Roll. I am the principal and the middle school teacher, one of the 2 middle school teachers here. And let's get rolling on week 1, day 1. So first, let's go over the agenda. So first on the agenda this morning, we are doing social studies. Social studies will encompass both current events, there's a lot to talk about there, and of course history. Then after that, we're going to be getting into a little bit of literature, and Coach Fryer is going to be helping us out a little bit there because we're finishing the book 20,000 Leagues Under the Sea. Then we have literature. After that, we're going to jump into science. And after that, we have some math. And then we're done. Hooray, done for the day. So again, social studies, literature, science, and then math. Miss Kimmy is also going to be teaching a grammar lesson that we're going to edit into the middle here since I am very bad at grammar. All right, let's jump into current events. So I was thinking about social studies quite a bit before coming into this lesson. When we're in class together, guys, I tell you a lot of things that are on my mind and on my heart. I try to help explain certain things to you, and a lot of times I do it in a very informal way. And I wasn't sure if that was the best way to do it right now because this is going to be put on the internet, and y'all know that if something's put on the internet, it could live forever. But hey, you know, why hide who we are? Let's just be who we are. So today I want to talk a little bit more about the economy. And everybody who is watching this already knows about the COVID-19 virus. If you were in my class before, we discussed that the COVID-19 virus comes from the novel coronavirus 2019, from when it was discovered. And so you can see a lot of that in the news. But I want to talk a little bit more about the economy, though, because I know a lot of you have had your parents or guardians, they've lost their jobs. And it can be a pretty scary time for families having to be alone at home. And so I want us to discuss that a little bit and to unpack it a little bit as we move forward. So hopefully you can understand the situation and you can understand why the situation doesn't necessarily have to affect you negatively in the long term because of where you're at and where you're going. So first up, let's define a few words using Mr. Roll's very simple shorthand. So first up, let's talk about the word economy or economics. Okay? When we talk about the word economy or economics, what we're really talking about is the sum total of all the business activity in an area. Okay? So again, this is not the perfect textbook explanation, but to keep things simple for now, let's just use that. The total business activity, the total business activity in an area. Okay, so it's important to understand that all economies grow and then shrink, and they grow and they shrink. And that's a normal part of the way that the economy works. Now, when an economy is growing, we call that an economic expansion, okay? And so that's our next vocabulary word to help kind of frame the discussion in a way that's easy to understand. So an economic expansion, when the businesses in an area are growing. Let's see here. The businesses in an area are growing. All right, and then the opposite of that, when the businesses in an area are shrinking, we call that an economic contraction. So, when we're in an economic expansion, businesses are growing. Generally, people are making a little more money this year than they were last year. People who maybe didn't have a job last year have found a job this year. And so when an economic expansion is happening, people generally feel better off today than they did a year ago. When we're in an economic contraction, however, it's the exact opposite. So people feel less secure. Businesses are shrinking and some are shutting down, and people are losing their jobs. Now, unfortunately, it is normal for economies to go through both phases. A lot of you have seen graphs on television or maybe on the internet, and these graphs look a little bit something like this, where they go up and then down and then up and down. Okay? And so graphs like this kind of show the way that the economy works. Usually the graph has something called GDP, or gross domestic product, on this side, or maybe it's stock prices, something like that. And then at the bottom it's time. Now, it's important to note, in general, the graph is always going up. So if we start at the beginning and we go to the end, the graph ends a lot higher than it began. And that's the way the American economy has been working for many, many years. And in fact, if if you're joining us from outside of the country, that's the way the world economy has worked for many, many years. The world economy continues to grow, and although we have certain small periods of decline where we see an economic contraction, it always starts growing again, and it gets better and better as time goes on. So, again, kids, economic expansions are these parts on the graph that are going up, and the economic contractions are the parts on the graph that are going down. And again, unfortunately, this is a natural part of business. This is a natural part of every economy. Now, over the past several years, we've been going through the longest economic expansion, at least in modern American history. So the American economy has been growing more and longer than it ever has in one consecutive period of time in all of American history. Now, I'm sure that those of you who are watching are familiar with that old saying, what goes up must come down. And so everybody has been waiting for the economic contraction. I want to leave you with the discussion with this thought. Everybody knew that the economy eventually would have to contract. Again, if you're watching this video, you're in 6th, 7th, or 8th grade, probably, okay? Now, we're going through an economic contraction today because of the COVID-19 virus. But guess what? You still have between 4 and 6 years before you're done with high school and you're entering college. You still have between 4 and 6 years before you have to start thinking about how you're going to support yourself and how you're going to pay your own bills. And 4 to 6 years is more than enough time for an economic contraction to end and an economic expansion to begin. Again, kids, we all knew that the contraction was coming. Everybody had planned for it. But this timing serves you the best. Because again, when it's time for you to start paying your bills and it's time for you to get a job, I am incredibly hopeful that there will be tons of jobs available when it's time for you to get it. So again, today it looks a little bit dark and it looks a little bit bleak. But kids, when you're ready to join the workforce, you're going to have a lot to look forward to. And so that's our current event lesson for the day. Please write these notes down because we're going to continue the conversation tomorrow.
Okay. Action.
All right, we're rolling, right? Okay, I got a second to go. Okay, all right, it's time to talk about history, and I just noticed as I was erasing our current events notes that I spelled a couple things wrong, so you don't have to email me. I know I spelled them wrong. Okay, let's continue. So we've been talking about the Civil War for quite a while. As you all know, the Civil War was America's bloodiest war by far. If you combine every single war that we've been in, aside from the Civil War, and add up the total amount of people who were killed, Civil War is still greater than all the other wars combined for American casualties. So again, super important war. Now, it's been almost 2 weeks since you guys have been in my class hearing all of the different characters and all of the stories about the war. So again, we have a few key players. Of course, everybody knows Abraham Lincoln, Secretary of State Seward. You guys know Secretary of the Treasury Chase, who was incredibly arrogant. You guys know about Bates. You guys know about Stanton, the Secretary of War. You know about Wells, who was Secretary of the Navy. Okay, so again, that's our cast of characters. Okay, today we are going to be spending about 30 minutes reviewing the events in the Civil War that led up to it, and then kind of what happened in the Civil War. Tomorrow we're going to be spending another 30 minutes watching videos and taking some quizzes, and then the day after that I think it's about 40 minutes working on that. If you have never studied the Civil War before because you are joining us from outside of the school, that's okay. These videos should bring you up to speed. If you are sick of the Civil War because you've had to sit in my class and listen to me, don't worry, this is the last time for the year, I promise. Okay, once we're done with this, we're good to go. After we're done reviewing all the Khan Academy materials, I will be attaching the PDF version of our test. Since I can't time it, and since I can't encourage you to use your notes, this test is going to be completely open book, completely open note, and heck, it's going to be completely open video. You can use the Khan Academy videos to complete it. Okay, I would very much like to assign this test to you on week 2, day 1. So we're going to spend this whole week kind of reviewing the Civil War, And then next week on Monday or whenever you do it, on week 2, day 1, we're going to be taking the test. All right, so let's go ahead. I need you to stop the video and click on the first link for the Khan Academy video if you're in my class. I know if you watched it or not, so definitely watch the videos. Thanks, guys.
The South Pole. I rushed up onto the platform. Yes, open sea. Barely a few sparse floes, some moving icebergs, a sea stretching into the distance, hosts of birds in the air, and myriads of fish under the waters, which varied from intense blue to olive green depending on the depth. The thermometer marked 3 degrees centigrade. It was as if a comparative springtime had been locked up behind that ice bank, whose distant masses were outlined on the northern horizon. "Are we at the pole?" I asked the captain, my heart pounding. "I have no idea," he answered me. "At noon we'll fix our position." "But the sun will show through this mist," I said, staring at the grayish sky. "No matter how faintly it shines, it will be enough for me," the captain replied. To the south, 10 miles from the Nautilus, a solitary islet rose to a height of 200 meters. We proceeded toward it, but cautiously, because this sea could have been strewn with reefs. In an hour, we had reached the islet. 2 hours later, we had completed a full circle around it. It measured 4 to 5 miles in circumference. A narrow channel separated it from a considerable shore, perhaps a continent whose limits we couldn't see. The existence of this shore seemed to bear out Commander Maury's hypothesis. In essence, this ingenious American has noted that between the South Pole and the 60th parallel, the sea is covered with floating ice of dimensions much greater than any found in the North Atlantic. From this fact, he drew the conclusion that the Atlantic Circle must contain considerable shores, since icebergs can't form on the high seas, but only along coastlines. According to his calculations, this frozen mass enclosing the southernmost pole forms a vast ice cap, whose width must reach 4,000 kilometers. Meanwhile, to avoid running around, the Nautilus heated 3 cable lengths from a strand crowned by superb piles of rocks. The skiff was launched to sea. 2 crewmen carrying instruments, the captain, Conseil, and I were on board. It was 10 o'clock in the morning. I hadn't seen Ned land. No doubt, in the presence of the South Pole, the Canadian hated having to eat his words. A few strokes of the oar brought the skiff to the sand, where it ran aground. Just as Conseil was about to jump ashore, I held him back. "Sir," I told Captain Nemo, "to you belongs the honor of setting foot on this shore. Of first setting foot on this shore." "Yes, sir," the captain replied, "and if I have no hesitation in reading this polar soil, it's because no human being until now has left a footprint here." So saying, he leaped lightly onto the sand. His heart must have been throbbing with intense excitement. He scaled an overhanging rock that ended in a small promontory, and there, mute and motionless, with crossed arms and blazing eyes, he seemed to be laying claim to these southernmost regions. After spending 5 minutes in this trance, he turned to us. "Whenever you're ready, sir," he called to me. I got out, Conseil at my heels, leaving the 2 men in the skiff. Over an extensive area, the soil consisted of that igneous gravel called tuff, reddish in color as if made from crushed rocks. The ground was covered with slag, lava flows, and pumice stones. Its volcanic origin was unmistakable. In certain localities, thin smoke holes gave off a sulfurous odor, showing that the inner fires kept their wide-ranging power. Nevertheless, when I scaled a high escarpment, I could see no volcanoes within a radius of several miles. In these Atlantic districts, As is well known, Sir James Clark Ross had found the craters of Mount Erebus and Mount Terror in fully active condition on the 167th meridian at latitude 77 degrees 32 minutes. The vegetation on this desolate continent struck me as quite limited. A few lichens of the species Usnea melanoxanthra sprawled out over the black rocks. The whole meager flora of this region consisted of certain microscopic buds, rudimentary diatoms made up of a type of cell positioned between two quartz-rich shells, plus long purple and crimson fucus plants, buoyed by small air bladders and washed up on the coast by the surf. The beach was strewn with mollusks, small mussels, limpets, smooth heart-shaped cockles, and especially some sea butterflies with oblong membrane-filled bodies whose heads are formed from two rounded lobes. I also saw myriads of those northernmost sea butterflies, 3 centimeters long, which a baleen whale can swallow by the thousands in one gulp. The open waters at the shoreline were alive with those delightful pteropods, true butterflies of the sea. Among other zoophytes present in these shallows, there were a few coral tree forms that, according to Sir James Clark Ross, live in these Atlantic seas at depths as great as 1,000 meters. Then small Alcyon coral belonging to the species Procellaria pelagica, also a large number of starfish unique to these climes, plus some feather stars spangling the sand. But it was in the air that life was superabundant. These various species of birds flew and fluttered by the thousands, deafening us with their calls. Crowding the rocks, other fowl watched without fear as we passed and pressed familiarly against our feet. These were auks, as agile and supple in water, where they are sometimes mistaken for fast bonito, as they are clumsy and heavy on land. They uttered outlandish calls and participated in numerous public assemblies that featured much noise but little action. Among other fowl, I noted some sheathbills from the wading bird family, the size of pigeons, white in color, the beak short and conical, the eyes framed by red circles. Conseil laid in a supply of them, because when they're properly cooked, these winged creatures make a pleasant dish. In the air, there passed sooty albatross with 4-meter wingspans, birds aptly dubbed vultures of the ocean. Also, gigantic petrels, including several with arching wings, enthusiastic eaters of seal that are known as quesadillas, and Cape pigeons, a sort of small duck, the tops of their bodies black and white. In short, a whole series of petrels, some whitish with wings trimmed in brown, others blue and exclusive to these Antarctic seas, the former so oily. I told Conseil that inhabitants of the Faroe Islands simply fit the bird with a wick, then light it up. With that minor addition, Conseil replied, these fowl would make perfect lamps. After this, we should insist that nature equip them with wicks in advance. Half a mile farther on, the ground was completely riddled with penguin nests, egg-laying burrows from which numerous birds emerged. Later, Captain Nemo had thousands of them hunted because their black flesh is highly edible. They brayed like donkeys, the size of a goose, with slate-colored bodies, white undersides, and lemon-colored neckbands. These animals let themselves be stoned to death without making any effort to get away. Meanwhile, the mists didn't clear, and by 11 o'clock, the sun still hadn't made an appearance. Its absence disturbed me. Without it, no sights were possible. Then how could we tell whether we'd reached the pole? When I rejoined Captain Nemo, I found him leaning silently against a piece of rock and staring at the sky. He seemed impatient, baffled. But what could we do? This daring and powerful man couldn't control the sun as he did the sea. Noon arrived without the orb of day appearing for a single instant. You couldn't even find its hiding place behind the curtain of mist, and soon this mist began to condense into snow. Until tomorrow, the captain said simply, and we went back to the Nautilus amid the flurries in the air. During our absence, the nets had been spread. I observed with fascination the fish just hauled on board. The Antarctic seas serve as a refuge for an extremely large number of migratory fish that flee from storms in the subpolar zones, in truth only to slide down the gullets of porpoises and seals. I noted some 1 decimeter southern bullhead, a species of whitish cartilaginous fish that are overrun with bluish-gray stripes and armed with stings. Then some Antarctic rabbitfish 3 feet long, the body very slender, the skin a smooth sliver of white, the head rounded, the top side furnished with 3 fins, the snout ending in a trunk that curved back towards the mouth. I sampled its flesh but found it tasteless, despite Conseil's views, which were largely disapproving. The blizzard lasted until the next day. It was impossible to stay on the platform. From the lounge where I was writing up the incidents of this excursion to the polar continent, I could hear calls of petrel and albatross cavorting in the midst of the turmoil. The Nautilus didn't stay idle, and cruising along the coast it advanced some 10 miles farther south amid the half-light left by the sun as it skimmed the edge of the horizon. The next day, March 20th, it stopped snowing. The cold was a little more brisk. The thermometer marked 2 degrees centigrade. The mist had cleared, and on that day, I'd hoped our noon sights could be accomplished. Since Captain Nemo hadn't yet appeared, only Conseil and I were taken ashore by the skiff. The soil's nature was still the same, volcanic. Traces of lava, slag, basaltic rock were everywhere. But I couldn't find the crater that had vomited them up. There as yonder, myriads of birds enlivened this part of the polar continent, but they had to share their dominion with huge herds of marine animals that looked at us with gentle eyes. They were seals of various species, some stretched out on the ground, others lying on drifting ice floes, several leaving or re-entering the sea. Having never dealt with man, they didn't run off at our approach, and I counted enough of them thereabouts to provision a couple of 100 ships. Ye gods, Conseil said. It's fortunate that Ned Land didn't come with us. Why so, Conseil? Because that madcap hunter would kill every animal here. Every animal may be overstating it, but in truth, I doubt we could keep our Canadian friend from harpooning some of these magnificent cetaceans. Which would be an affront to Captain Nemo, since he hates to slay harmless beasts needlessly. He's right, certainly, Conseil. But tell me, haven't you finished classifying these superb specimens of marine fauna? Master is well aware, Conseil replied, that I'm not seasoned in practical application when Master has told me these animals' names. They're seals and walruses. 2 genera, our scholarly Conseil hastened to say, that belong to the family Pinnipedia, order Carnivora, group Ursula, subclass Monodelphia, class Mammalia, branch Vertebrata. Very nice, Conseil, I replied, but these 2 genera of seals and walruses are each divided into species, and if I'm not mistaken, we now have a chance to actually look at them. Let's. It was 8 o'clock in the morning. We had 4 hours to ourselves before the sun could be productively observed. I guided our steps towards a huge bay that made crescent-shaped incision in the granite cliffs along the beach. There, all about us, I swear that the shores and ice floes were crowded with marine animals as far as the eye could see, and I involuntarily looked around for old Proteus, that mythological shepherd who guarded King Neptune's immense flocks. To be specific, these were seals. They form distinct male and female groups, the father watching over his family, the mother suckling their little ones, the stronger youngsters emancipated a few paces away. When these animals wanted to relocate, they moved in little jumps made by contracting their bodies, clumsily helped by their imperfectly developed flippers, which, as with their manatee relatives, form actual forearms. In the water, their ideal element, I must say these animals swim wonderfully thanks to their flexible backbones, narrow pelvises, close-cropped hair, and webbed feet. Resting on the shore, they assumed extremely graceful positions. Consequently, their gentle features, their sensitive expressions equal to those of the loveliest women, their soft, limpid eyes, their charming poses, led the ancients to glorify them by metamorphosing the males into sea gods and the females into mermaids. I drew Conseil's attention to the considerable growth of the cerebral lobes found in these intelligent cetaceans. No mammal except man has more abundant cerebral matter. Accordingly, seals are quite capable of being educated. They make good pets, and together with certain other naturalists, I think these animals can properly be trained to perform yeoman service as hunting dogs for fishermen. Most of these seals were sleeping on the rocks or the sand. Among those properly termed seals, which have no external ears, unlike sea lions whose ears protrude, I observed several varieties of the species 3 meters long, with white hair, bulldog heads, and armed with 10 teeth in each jaw, 4 incisors in both the upper and lower, plus 2 big canines shaped like the fleur-de-lis. Among them slithered some sea elephants, a type of seal with a short, flexible trunk. These are the giants of the species, with a circumference of 20 feet and a length of 10 meters. They didn't move as we approached. Are these animals dangerous, Conseil asked me. Only if they're attacked, I replied. But when these giant seals defend their little ones, their fury is dreadful, and it isn't rare for them to smash a fisherman's longboats to bits. They're within their rights, Conseil answered. I don't say nay. 2 miles farther on, we were stopped by a promontory that screened the bay from southerly winds. It dropped straight down to the sea, and surf foamed against it. From beyond this ridge there came fearsome bellows, as a herd of cattle might produce. Gracious Conseil, put in a choir of bulls. No, I said, a choir of walruses. Are they fighting with each other? Either fighting or playing. With all due respect to Master, this we must see. Then see it we must, Conseil. And there we were, climbing these blackish rocks amid sudden landslides and over stones slippery with ice. More than once, I took a tumble at the expense of my backside. Conseil, more cautious or more stable, barely faltered and would help me up, saying, if Master's legs would kindly adopt a wider stance, Master will keep his balance. Arriving at the topmost ridge of this promontory, I could see vast white plains covered with walruses. The animals were playing among themselves. They were howling not in anger but in glee. Walruses resemble seals in the shape of their bodies and the arrangement of their limbs, but their lower jaws lack canines and incisors, and as for the upper canines, they consist of 2 tusks, 80 centimeters long, with a circumference of 33 centimeters at the socket. Made of solid ivory, without striations, harder than elephant tusks, and less prone to yellowing, these teeth are in great demand. Accordingly, walruses are the victims of a mindless hunting that will soon destroy them all, since their hunters indiscriminately slaughter pregnant females and youngsters, and over 4,000 individuals are destroyed annually. Passing near these unusual animals, I could examine them at my leisure, since they did not stir. Their hides were rough and heavy, a tan color leaning towards reddish-brown. Their coats were short and less than abundant. Some were 4 meters long, more tranquil and less fearful than their northern relatives. They posted no sentinels on guard duty at the approaches to their campsite. After examining this community of walruses, I decided to return in my tracks. It was 11 o'clock, and if Captain Nemo found conditions favorable for taking his sights, I wanted to be present at the operation, but I held no hopes that the sun would make an appearance that day. It was hidden from our eyes by clouds squeezed together on the horizon. Apparently, the jealous orb didn't want to reveal this insatiable spot on the globe to any human being. Yet I decided to return to the Nautilus. We went on a long, steep, narrow path that ran over the cliff summit. By 11:30, we had arrived at our landing place. The beached skiff had brought the captain ashore. I spotted him standing on a trunk of basalt. His instruments were beside him. His eyes were focused on the northern horizon, along which the sun was sweeping in its extended arc. I found a place near him and waited without speaking. Noon arrived, and just as on the day before, the sun didn't put in an appearance. It was sheer bad luck. Our noon sights were still lacking. If we couldn't obtain them tomorrow, we would finally have to give up any hope of fixing our position. In essence, it was precisely March 20th. Tomorrow, the 21st, was the day of the equinox. The sun would disappear below the horizon for 6 months, not counting refraction, and after its disappearance, the long polar night would begin. Following the September equinox, the sun had emerged above the northerly horizon, rising in long spirals until December 21st. At that time, the summer solstice of the southernmost districts, the sun had started back down, and tomorrow it would cast its last rays. I shared my thoughts and fears with Captain Nemo. "You're right, Professor Aronnax," he told me. "If I can't take the sun's altitude tomorrow, I won't be able to try again for another 6 months. But precisely because sailors' luck has led me into those seas on March 21st, it will be easy to get our bearings if the noonday sun does appear before our eyes." "Why easy, Captain?" "Because when the orb of day sweeps in such long spirals, it's difficult to measure its exact altitude above the horizon, and our instruments are open to committing serious errors." "Then what can you do?" "I only use my chronometer," Captain Nemo answered me. "At noon tomorrow, March 21st, if after accounting for refraction, the sun's disk is exactly cut in half by the northern horizon, that will mean I'm at the South Pole." "Right," I said. "Nevertheless, it isn't mathematically exact proof because the equinox needn't fall precisely at noon." "No doubt, sir, but the air will be under 100 meters, and that's close enough for us until tomorrow then." Captain Nemo won't be back on board. Captain Nemo went back on board. Conseil and I stayed behind until 5 o'clock, surveying the beach, observing and studying. The only unusual object I picked up was an ox egg of remarkable size, for which a collector would have paid more than 1,000 francs. Its cream-colored tint, plus the streaks and markings that decorated it like so many hieroglyphics, made it a rare trinket. I placed it in Conseil's hands, and holding it like a precious porcelain from China, that cautious, sure-footed lad got it back to the Nautilus in one piece. There I put this rare egg inside of one of the glass cases in the museum. I ate supper, feasting with appetite on an excellent piece of seal liver, whose flavor reminded me of pork. Then I went to bed, but not without praying, like a good Hindu, for the favors of the radiant orb. The next day, March 21st, bright and early at 5 o'clock in the morning, I climbed onto the platform. I found Captain Nemo there. "The weather is clearing a bit," he told me. "I have high hopes. After breakfast, we'll make our way ashore and choose an observation post." This issue settled, I went to find Ned Land. I wanted to take him with me. The obstinate Canadian refused, and I could clearly see that his tight-lipped mood and bad temper were growing by the day. Under the circumstances, I ultimately wasn't sorry that he refused. In truth, there were way too many seals ashore, and it would never do to expose this impulsive fisherman to such temptations. Breakfast over, I made my way ashore. The Nautilus had gone a few more miles during the night. It lay well out, a good league from the coast, which was crowned by a sharp peak 400 to 500 meters high. In addition to me, the skiff carried Captain Nemo, 2 crewmen, and the other instruments, in other words, a chronometer, a spyglass, and a barometer. During our crossing, I saw numerous baleen whales belonging to the 3 species unique to these southernmost seas. The bowhead whale, or right whale according to English, has no dorsal fin. The humpback whale from the genus Ballanthropra, in other words, winged whales, beasts with wrinkled bellies and huge whitish fins that genus name regardless, do not yet form wings. And the finback whale, yellowish brown, the swiftest of all cetaceans. This powerful animal is audible from far away when it sends up towering spouts of air and steam that resemble swirls of smoke. Herds of these different animals were playing about in the tranquil waters. I could easily see that this Antarctic polar bear basin now served as a refuge for those cetaceans too relentlessly pursued by hunters. I also noted long, whitish strings of salps, a type of mollusk found in clusters, and some jellyfish of large size that swayed into the eddies of the billows. By 9 o'clock, we had pulled up to the shore. The sky was growing brighter, clouds were fleeing to the south. Mists were rising from the cold surface of the water. Captain Nemo headed toward the peak, which he had no doubt planned to make his observatory. It was an arduous climb over sharp lava and pumice stones in the midst of air often reeking with the sulfurous fumes from the smoke holes. For a man out of practice at treading land, the captain scaled the steepest slopes with a supple agility I couldn't equal, and which would have been envied by hunters of Pyrenees mountain goats. It took us 2 hours to reach the summit of this half-crystal, half-basalt peak. From there, our eyes scanned a vast sea, which scrawled its boundary line firmly against the background of the northern sky. At our feet, dazzling tracks of white. Over our heads, a pale azure, clear of mists. North of us, the sun's disk, like a ball of fire already cut by the edge of the horizon. From the heart of the waters, jets of liquid rising like hundreds of magnificent bouquets. Far off, like a sleeping cetacean, the Nautilus. Behind us, to the south and east, an immense shore, a chaotic heap of rocks and ice whose limits we couldn't see. Arriving at the summit of this peak, Captain Nemo carefully determined its elevation by means of his barometer, since he had to take this factor into account in his noon sights. At 11:45, the sun, by then seen only by refraction, looked like a golden disk, dispersing its last rays over this deserted continent and down to those seas not yet plowed by the ships of man. Captain Nemo had brought a spyglass with a reticular eyepiece, which corrected the sun's refraction by means of a mirror, and he used it to observe the orb sinking little by little along a very extended diagonal that reached below the horizon. I held the chronometer. My heart was pounding mightily. If the lower half of the sun's disk disappeared just as the chronometer said, noon, we were at the right pole. Noon, I called. The South Pole. Captain Nemo replied in a solemn voice, handing me the spyglass, which showed the orb of day cut into two exactly equal parts by the horizon. I stared at the last rays wreathing this peak, while shadows were gradually climbing its gradients. Just then, resting his hand on my shoulder, Captain Nemo said to me, "In 1600, sir, the Dutchman Gertique was swept by storms and currents, reaching latitude 64 degrees south and discovering the South Shetland Islands. On January 17th, 1773, the famous Captain Cook went along the 38th meridian, arriving at latitude 67 degrees 30 minutes, and on January 30th, 1774, along the 109th meridian, he reached latitude 71 degrees and 15 minutes. In 1819, the Russian Bellinghausen lay on the 69th parallel, and in 1821, the 66th at longitude 111 degrees west. In 1820, the Englishman Bransfield stopped at 65 degrees. That same year, the American Morrell, whose reports are dubious, went along the 42nd meridian, finding open sea at latitude 70 degrees 14 minutes. In 1825, the Englishman Powell was unable to get beyond 62 degrees. That same year, a humble seal fisherman, the Englishman Weddell, went as far as latitude 70 degrees 14 minutes on the 35th meridian, and as far as 74 degrees 15 minutes on the 36th. In 1829, the Englishman Forster, commander of the Chandelier, laid claim to the Antarctic continent in latitude 63 degrees 26 minutes and longitude 66 degrees 26 minutes. On February 1st, 1831, the Englishman Briscoe discovered Enderby Land at latitude 68 degrees 50 minutes, Adelaide Land at latitude 67 degrees on February 5th, 1832, and Graham Land at latitude 64 degrees 45 minutes on February 21st. In 1838, the Frenchman Dumont d'Urville stopped at the Ice Bank in latitude 62 degrees 57 minutes, sighting the Louis Philippe Peninsula. On January 21st, 2 years later, at a new southerly position of 66 degrees 30 minutes, he named the Adélie coast, and 8 days later, the Clare coast at 64 degrees 40 minutes. In 1838, the American Wilkes advanced as far as the 69th parallel on the 100th meridian. In 1839, the Englishman Bellini discovered the Sabrina coast at the edge of the polar circle. Lastly, on January 12, 1842, with his ships, the Erebus and the Terror, the Englishman Sir James Clark Ross found Victoria Land at latitude 70 degrees 56 minutes and longitude 171 degrees 7 minutes east. On the 23rd of that same month, he reached the 74th parallel, a position denoting the farthest south attained until then. On the 27th day, he lay at 76 degrees 8 minutes on the 28th let's try that again. On the 27th, he lay at 76 degrees 8 minutes on the 28th at 77 degrees 32 minutes. On February 2nd, at 78 degrees 4 minutes, and late in 1842, he returned to 71 degrees but couldn't get beyond it. Well now, in 1868, on this 21st day of March, I myself, Captain Nemo, have reached the South Pole at 90 degrees, and I hereby claim this entire part of the globe equal to 1/6 of the known continents. In the name of which sovereign, Captain? In my own name, sir. So saying, Captain Nemo unfurled a black flag bearing a gold N on its quartered bunting. Then, turning toward the orb of day, whose last rays were licking at the sea's horizon, "Farewell, O sun," he called. "Disappear, O radiant orb. Retire beneath this open sea, and let 6 months of night spread their shadows over my new domains."
All right, ladies and gentlemen, I think Coach Fryer did a really good job with that. Your homework for this evening is to read the next chapter. I believe it's Accident or Incident. Again, read the next chapter, Accident or Incident. All right, let's move on to the next lesson.
Action.
All right, so today in our science lesson, I'm going to talk to you a little bit and bore you, and then we're going to be watching a very sophisticated, fancy video. I think it's actually a video that's a lot of fun. But today we're learning about the physics concept of work. Work. So, the physics concept of work is different than the work that you and I would normally think of. So, I'm going to grab this weird device here. This is a shutter, and so we've been having to do all kinds of weird lighting things this week, and so this is one of the shutters that we have had to work some of the ancient light kits that we use to do our filming. So, if I hold this shutter and I hold it completely still, am I exerting any force? Well, yes, I am. I am pressing this ancient shutter against my body to keep it from falling. But in the physics definition, I am not doing any work. How can it be possible for somebody to be exerting force on something but not be doing any work? Let me give you another example. Let me put this down here. If I press against this back board here, and I lean against it, and I push on it with all of my might, I am not doing any work under a physics definition. I am exerting force, but from a physics point of view, I am doing no work. In physics, in order to be considered work, we have to have force and displacement. Or another way to put it is we have to have force and movement. Something has to be moved. So if I pick up this shutter again, if I pick up this shutter and I'm applying force against my body so that the shutter does not fall, and I take a step to the side, I am doing work. But the work that I'm doing is not considered the force, keeping this against my body to keep it from falling. The work that I'm doing is the movement of the shutter going back and forth horizontally. Because from a physics point of view, we calculate work by calculating the amount of force and the amount of movement or displacement that we put on the object. All right, so that might have been very confusing for you. I'm going to send you over to this video. Now, I want to tell you a little bit about this video. This video starts off very simple, and then around the 3 or 4 minute mark, it gets a little complicated. If you kids are not used to people from South Asia, there is a gentleman who's teaching the video with a bit of a South Asian accent, so you should be able to turn on subtitles in YouTube so you can read what he's saying as well. So hopefully that will be helpful. But I want you to watch the video, and if you can keep with the video for the first 3 or 4 minutes, you should be good to go. Tomorrow we're going to continue talking about force and work, and we're going to be watching another video that is maybe a little bit less intense than this one. But again, I hope you like it. I hope you pay attention. Let's get down to work.
Okay. Great.
Today I want to give you a brief overview of what you're going to do on Khan Academy today. I'm going to look at parts of speech, and this is definitely a review. We're going to go way back to the beginning and talk about nouns. And we all know that nouns are person, places, or things, right? Persons. And we're going to concern ourselves today with 4 very basic types of nouns. Singular nouns, from the word single, which means one, and plural nouns, which is from the Latin plus, which means more. We'll also look at identifying concrete nouns. And think about concrete as a block of concrete. It's very solid and you can touch it. Abstract nouns, however, are talking about ideas, and they're usually from the mind.
So we're about to get started on math, but I want to talk about the different math groups that we have before we begin. So in Miss Kimmy's class, our 6th and 7th grade teacher, she has 2 math groups. And in my class, we also have 2 math groups. And so for me, math group 1 is a pre-algebra math. It's using a pre-algebra book, a pre-algebra curriculum. Math group 2 uses a full algebra 1-2 curriculum. So if you are already in pre-algebra, you should stick around for math group 1. If you are already in full algebra, then stick around for math group 2. Now, if you struggle in math a little bit and you're not so sure about how to do math things and it's just not your best subject, I would actually recommend going back to Miss Kimmy's class and doing her math group 2. Her math group 2 is helpful. It's right around pre-algebra, maybe a little bit before pre-algebra. For her math group number 1, if you really have a tough time with math and you really need a little bit of review, you can even go back to Miss Kimmy's math group 1 class and follow along with those lessons. I believe this week they're reviewing multiplication and division with 2 digits. So again, if you are pretty good at math and you feel solid on pre-algebra, go ahead and stick with us here. If you are great with math and you're solid for algebra, go ahead and again stick with us. If you would like a little bit more review, however, go ahead and switch over and find on the website davincitree.academy, click on the 6th, 7th grade class, and go to Miss Kimmy's class. Right at the end of the video there, she's talking about her math classes. Okay, that's an explanation of our math groups. Let's go ahead and get started.
And action.
Excellent. So right now, let's get started with Math Group 1. So again, this is week 1, day 1, Math Group 1. So today we are going to talk about area, an area of a parallelogram. So let's break those two things down. First, what is area? So if we are going to speak in very simple terms, area is the measurement of the space inside of a shape, okay? Measurement of space inside of a shape. So one day when you kids are out like apartment hunting or house hunting, you're going to want to know how many square feet the apartment or the house has. The number of square feet will tell you how big the place is. If you're all by yourself, maybe something small, like a 300 to 500 square foot studio would be enough for you. If you have a couple of roommates, though, you probably want something that's closer to 1,000 to 1,500 square feet. Okay? So let's first talk about finding the area of a simple shape, like a rectangle. Okay? So if I have a rectangle here, and let's just, for example, say that the rectangle is 5 tall and 3 wide. I would find the area of this rectangle by multiplying the height and the width. So again, it's very simple. I would just take 5 times 3, and it'd give me 15. Now, if this rectangle were representative of feet, so if it were 5 feet by 3 feet, I would need to make sure that I put that in my units. So it'd be 5 feet times 3 feet, and I would get 15 feet squared. Okay? Now, some of you may not have seen squared before, but if you don't know what squared means that the number is multiplied by itself. So for instance, if I was doing something like 9 squared, the answer would be 81, because I would be taking 9 times 9, and that gives me 81. Now, in the case with the feet, right here, I have feet right there, I have feet right here. Feet times feet equal feet squared. Any unit times any unit equals that unit squared. So for instance, if I had something like inches times inches, that would be inches squared, because it just means that unit times itself. Now, we can also think of that in a different way. We can think of that squared almost like dimensions. So when we think about something that is two-dimensional, that means that it's flat and it's just sitting there on a flat surface. If we think of something that's three-dimensional, that means that all of a sudden it's popping out at you, right? And so if we have a flat piece of paper that's laying on a table, so if we have a table surface, right? And so I just have like a little piece of paper here, right? And maybe there's some writing on it, okay? That piece of paper would be two-dimensional. It's laying flat on the table surface, okay? But if maybe a little bit down the way here, I had a little Lego tower. And so maybe you have a little brother or sister and they're building a tower out of Legos. Maybe you're the one building the tower of Legos. No judgment, it's okay. I'm a dad, I play with Legos all the time, all right? And so you have a little tower here. This tower would stand up. And because this tower stands up, it works in 3 dimensions, okay? And so the units that we would describe this flat piece of paper with are two-dimensional. So again, if this paper was 5 inches here and 3 inches here, the area of this paper would be 15 inches squared. Again, 5 times 3 is 15, and inches times inches equals inches squared. If we have a 3-dimensional shape, however, we would have to multiply 3 numbers together, and we are actually not getting that deep into it today. That is not area, that's something called volume. And again, we'll talk about that later. But again, today we're just talking about area, the measurement of space inside of a shape. And that's how you calculate the area of a simple shape like a rectangle. I'll give you a second to process that. You might be thinking to yourself, Mr. Roll, this is all super easy. I learned this back in 4th grade. Oh, this is so silly. I'm going to stop watching the video now and go watch Netflix. Don't do that, okay? Hold on. Okay, let's get to the meat and potatoes of today's lesson, all right? what if we have a shape that's a parallelogram? That's not a good square or rectangle. Now first, for those of you who don't remember what a parallelogram is, a parallelogram, I don't know if I spelled that right. This isn't spelling class though, so I'm going to get away with it. Don't tell Miss Kimmy. Parallelogram is a figure, a shape with four sides. Shape with four sides. And all sides are parallel. If you don't remember what parallel is when we have two different lines that run right next to each other. And in math, a line goes on forever and ever and ever in all directions because math is all pretend and lines are all imaginary. And so if two lines are perfectly parallel, they run side by side to each other. And let's say if these two lines are like 5 inches apart, maybe 6 inches apart, forever and ever, these two lines would run 5 or 6 inches apart from each other and they would never touch. And they would go like this forever. Okay, and nothing would ever happen between them. They would never connect. Kind of like me and that girl in high school that I really liked. It's a thing. So on a parallelogram, we have a shape with four sides, and all the sides are parallel with each other. Okay, so let's say that we have a parallelogram. And it looks something like this. And again, you have to use your imagination and pretend because I'm not that good of an artist. Okay. And so this side is parallel with this side, and this side is parallel with this side, okay? So when we're measuring a parallelogram, okay, it's almost like a rectangle that fell over a little bit, okay? Or actually it's the other way, like that, right? When we're measuring a parallelogram and trying to find the area of the parallelogram, we have to do two very simple things, okay? First, we have to measure what we call the base. So we have to measure this part right here, the bottom part, or the base. Now, the base is pretty easy because the base starts here and ends over here. And so we just have to figure out how long that is. Easy peasy. Next, we have to measure the height, okay? Now, the height is not the length here, okay? This is not the height. This is going to be a little bit longer than the height because actually, the height doesn't measure this side. It's how tall it goes up from here to here. So we're actually measuring like this. And I apologize if the words escape me right now. But again, we're not measuring the length of this side. Again, we are not measuring the length of this side. We're actually measuring how tall the shape is. Okay? So we take the base and we take the height. And when we calculate the area of this shape, it is exactly the same as if it were a simpler shape, like a rectangle or a square. All we have to do is take the base and times it by the height. The base times the height will give us the area. Now, you may not understand how that works, so let's unpack this just a little bit. If this is a perfect parallelogram, and I got out a pair of scissors, I could actually cut off this side, just like that, okay? And with this side that I just cut off right here, I could reattach it to this side. And if I cut off this side and I reattached it over here like that, I would actually make a perfect rectangle, okay? So it would come together. And again, you got to forgive me because this is not art class, this is math class, nor is it spelling class. Again, don't tell Miss Kimmy if I spelled something wrong, or email me because, who has time for that, right? But again, if we cut off this side and we put it on the other side, it would make a perfect rectangle, okay? And a rectangle, again, it's just the base times the height. It gives us the area. So on a parallelogram like this, we just take the base times the height, and it will give us the area of the shape. And that's it. That's all we have to do. Today's lesson's easy, okay? Find the base, find the height, multiply them together. Make sure that you're multiplying your units correctly. So if it's inches times inches, we get inches squared. If it's meters times meters, it's meters squared. whatever the unit is, and we're done, okay? So folks, if you don't understand the lesson, you can send me an email, or you can just re-watch the lesson. I'm also going to make you watch this Khan Academy video that just re-explains everything I explained to you. So if you're at home and you're bored, guess what? Get ready to be more bored because we have another video for you. All right, that's it for Group 1. All right, Group 2, it's your turn. So, Group 2, my 10 kiddos, and anybody else who wants to join us. Today, we are solving linear systems by graphing. Okay, Group 2 in your algebra book, this is on page 346. I will also take parts of this and kind of post it in a PDF, so those of you who don't have the book can follow along with us. Some of these Group 2 lessons get kind of intense, and it's hard for me just to explain it all by talking. After we're done with this lesson, I should have a Khan Academy video for you to watch as well. Hopefully Khan Academy does a better job than me explaining it. So let's go ahead and begin. So when we have a system of, when we have a linear system, first let's talk about that, okay? You all are familiar with a linear equation, okay? Everybody should be familiar with an equation like x plus y equals 9,000, okay? That's an easy linear equation. You guys can turn that into y equals mx plus b and put it on a graph, no problem, with your eyes closed while you're asleep, okay? So that is a linear equation. What we're learning about in this lesson is a linear system. So a linear system has one or more linear equations in them, all right? And so to start out, we have this linear equation, and then I'm going to put another linear equation on the board. So we're going to do 0.05, and again, if you're watching in the book, I'm just copying right out of the book. So 0.05x plus 0.06y equals 510. Okay? Now, the thing is, this is a system of equations. So, whoops, as I stumble about, it's very late here, guys, I'm sorry. All right, so the x in this first equation is the exact same x as in the second equation. Okay, so in a system of equations, the x's and the y's and all the variables from equation to equation are all the same. So the x here is going to be the exact same amount or value as the x here. The y here is going to be the exact same value or the exact same amount as the y here. And so given that these two equations have the exact same variables, how do we solve them? Now first, the way that I can tell that this equation and this equation are related, the way that I can tell that they're related is if I have one of these silly little bracket things on them. So when you have a system of equations, there's always going to be a bracket on it, like so. So again, if you ever see equations and they have the bracket on it, that means that these variables are connected to each other, okay? No bracket, no connection, okay? Again, if there's no bracket there, this x could be anything and this x could be something different. But when the bracket's there, the x, the y, and the y are the same, okay? Now, there are two ways to go about solving these things. The first way is algebraically, okay? If I have an ordered pair, an xy value, that I want to check and see if it works, I can simply plug in the x and the y value for both to confirm that they work. That's the first way. And so the first way of solving this, again, way number one, is using algebra, or algebraic check. Whenever I say algebraic check, I always think of Finn the human from Adventure Time when he goes, algebraic. Maybe if I'm lazy later on, I'll insert a drop or something. Anyway, so way number one is the algebraic check, or plug and chug. Plug and chug. So we just plug in the values and see if they work, okay? Way number two, which is the way that we are going to do for the very first time today, is by graphing. This is the graph and check method. So first, for this set of values here, we're going to be plugging in two numbers, and
Matt, I'm just going to check this while you're dubbing.
Okay.
Hold on a second. because it smells like it's burning.
It does smell. Oh, it's this.
That'll help, right?
It just fell right back.
Huh?
I think if it's a little glary, it's okay, right? As long as it's not. Is that too much?
I can't tell till you get there. Well, if you don't move any more over this way, it'll be okay. Just
Okay.
stay right there.
Sounds like a deal. Okay. Oh, it actually doesn't give me any numbers to plug and chug in here.
Okay, sorry.
All right. Oh, we're still rolling. Okay.
I just get rolling. Yeah.
Okay.
Rolling.
So let me plug in two numbers that don't work. And we're going to see that they don't work. Okay. Now,
Well, let's just repeat that, and I'll just change the frame.
sure.
Just let me plug in. Okay, rolling.
So let me plug in two numbers that don't work to kind of review and show you how this does work. So the numbers have to not only satisfy the first equation, but they also have to satisfy the second equation. So, for instance, if I have an x value, so let's just say that I'm guessing, and I put my x value as 3,000. So x equals 3,000. And again, I'm guessing, and I'm using numbers that don't work for both systems. And let's say I make my y value 6,000. Okay? Now, in this first equation, if I plug in the numbers, 3,000 and 6,000, it actually works. Okay? So right here, if I say 3,000 plus 6,000, it indeed equals 9,000. I'm good to go. So, system of equations, equation 1, we're good. Okay? But these numbers have to satisfy both equations. All right? So let's go ahead and let's try it in the second equation. Now, because I'm lazy, I'm going to use a calculator here so that it doesn't take us too long. So we have 3,000 times, let's see here, 0.05. And that gives us 150. So we have 0.05 times 3,000 plus 0.06 times 6,000, okay, equals 510. And so 0.05 times 3,000 equals 150, okay? And now we multiply this, 6,000 times 0.06, that gives us 360. Wait, does it actually work? You got to be kidding me. Well, crap, it works. I just guessed, okay? All right, well, anyway, I guessed and it does work. Do you guys, I'm a terrible teacher. Anyway, so do you see how 3,000 and 6,000, you plug it in the first equation, it works. We plug it in the second equation, and I swear to goodness that I didn't plan this ahead of time, because if you're in my class, you know I don't plan for anything, okay? It equals 510. So these actually work, and this is the solution to this system of equations. Is this in the book somewhere, and I just like subconsciously processed it? No, it is not. I just had a very lucky guess. All right, let's go on to the next way that we solve these things. Okay, so this is the algebraic check. This is the plug and chug. This is the, we have a value, we plug it in both equations. If it works, great. If it doesn't, it's not the right answer, okay? This is your algebraic check. Let's move on to the graphical check. The graphical check is exactly what it sounds like. We graph it, okay? So I'm going to copy the system of equations out of the book from page 347. So we have, let's see here, x plus y equals negative 2. 2x, take away 3, y equals negative 9, system bracket. I really miss having you kids here so I can just be like, hey, Hazel, Aiden, read the problem. Let me write it down. So Marius, tell Aiden to stop kicking you. You know, I miss you guys. Anyway, so here's our system of equations. So if we're solving by graphing, we have to throw both of these into y equals mx plus b. Then we graph them. And the place on the graph where the two lines intersect, where these two lines connect, that's our answer. Okay? So first step, let's put these in y equals mx plus b. I'm just going to well, for this one, this is easy. We can just look at this, and we can tell that this one is y equals negative x, take away 2. On this one, let's solve and make sure Mr. Roll doesn't make any more embarrassing math errors on the internet for the whole world to see. Okay, so we're going to take away 2x, negative 3y equals negative 2x, take away 9. We divide both sides by negative 3. That cancels out. That gives us a y. Negative and a negative gives us a positive 2/3 x. A negative and a negative gives us a plus 3. So this turns into y equals 2/3 x plus 3. There we go. Okay. Now that we have these both in y equals mx plus b, we can graph them. Again, be kind. My graph is not going to be perfect because, you know, it never is. Okay, so we have to start at the negative 2. 2, 1, 2, 3, 4, 5. So we start at negative 2 right here. And so the slope we know is down 1 over 1. So we go down 1 over 1 right there, down 1 over 1 right there. So we get a line that's more or less something a little bit like this. Wait, okay, up 1 over 1, be there, be there. Sorry guys, my line is really crooked. Let me try to make it a little bit straighter. Okay, there we go. Something a little bit like that. Then on this one we have to go up 3. So we're starting 1, 2, 3. And we're going up 2 over 3. Oh, so in this case we'd go up 2 over 3. 2, 3. And we have to go backwards. Let's go down 2 over 3. 1, 2, 3. Okay. Okay. So you see, this is the top graph. This is the bottom graph. We graph them both, and as we graph them, this intersection point right here, that's going to be our answer. Okay? So it is, let's see here, negative 1, negative 2, negative 3. So we're sitting at negative 3, positive 1. Let's go ahead and double check in the book, make sure I didn't embarrass myself on not so live television. Negative 1, negative 2, Yep, negative 3, negative 1. So again, ladies and gentlemen, when we are doing a graphical check to solve a system of equations, all we're doing is we're turning the equations into y equals mx plus b. We're graphing them on the same graph. We're figuring out where they cross each other. And where they cross each other, that point is going to be the solution for both equations. Okay? Right now I'm going to throw you over to the Khan Academy video, and we're going to end our day by watching Khan Academy. Anyway, it's been a real pleasure. It's really weird doing these things without you guys here. I know that some of you all are making fun of me and I don't get to be part of the joke, which makes me sad. But I know that you guys are probably at home anyway, kind of wishing that you could be here. I know I wish you could be here too. So folks, have a great one. Enjoy your Khan Academy videos, and I'll see you tomorrow.